Hi, the first thing we're going to take a look at today is we are first going to discuss the different types of numbers. So we have this list of numbers here. So think about, what do you know about these words? Natural numbers, whole numbers, integers, rational numbers, and irrational numbers. So these are all the numbers that you have worked with in your math career, and these are the ones that we're going to start with this year and adding on to eventually. So first off, natural numbers are sometimes called counting numbers. So in addition to natural, you could also use the word counting numbers here. And think about counting, think about like playing hide and go seek or something like that. And when you have to count, what are the numbers that you would use? All right, so natural numbers are clearly then 1, 2, 3, 4. All right, and so on, and so on, and so forth. And then we go on to whole numbers. Well, whole numbers indicating, think about it, they're whole, meaning there's not parts of them, so no fractions. But that also would be the natural numbers. So all the things we have up above in the natural numbers also would be part of the whole numbers. But then there's also one other possibility. A whole number is also 0. So if you think about it, whole numbers, notice I have the exact same list there, 1, 2, 3, 4, and so on, but I also have that 0 right there. So notice the natural numbers fit inside the whole numbers, so the whole numbers are the natural numbers plus the number 0. Moving on to the integers. All right, what are integers? Well, integers, you can think of integers as numbers on a number line. All right, usually you put whole numbers on a number line, but also what other numbers are possible to put on a number line besides the numbers right here? Well, other numbers that would be on the number line are then also the negative numbers. So if you look here, you can notice, see how I see 0, 1, 2, and so on? Well, I also have then the negative values there. So integers are whole numbers, and then these are, remember, called the opposites. -1 is the opposite of +1. All right, so those are integers. Now, to talk about rational and irrational, we're actually going to go to another slide because their definitions are a little more complicated. So here we have rational versus irrational as the title there. What's the difference? Well, the rational versus irrational, the real number is really made up of two subsets. So rational numbers are very easily, we could say, they are numbers that can be written as a fraction. So 1/2, 2/3, all right, those can be written in fraction form. What else do I know about those numbers? Like 1/3 or 1/2 or 1/4 or even 3/4. Those are all numbers that are written as decimals, and the decimals, they either terminate or repeat. All right, so think about that. If I have 1/2, well, that's the same as 0.5. That is a terminating decimal because it just stops after the 5. All right, if I had 1/3, well, that's 0.3333 repeating, right? That's a rational number. Well, what do you suppose then it means to be irrational? Well, actually, the one definition for irrational numbers, you could simply say irrational numbers are not rational, right? That's as simple as it can get. That's how mathematics can work. You can just say that. Now, there's a better definition, but that's what one way you could say it is they're not rational. But we're going to go a little more into depth, and I'm going to blast you away with this one. Ready? They are numbers that cannot be written in fraction form, right? Instead of up above where I had can, irrational numbers cannot be written in fraction form. And I bet you could figure out the next thing I'm going to pull over. They are numbers that then are written as decimals, and they neither terminate nor repeat. Well, what's a decimal you can think of that doesn't terminate and it doesn't repeat? I hope most of you came up with pi right there. That's an irrational number. Okay, that cannot be written as a fraction. Anything that is a square root, the square root of 2, the square root of 3, those are irrational numbers. what about the square root of 4? Where would the square root of 4 fit? Right? That actually should be up there because that becomes 2. And 2 is a fraction, 2 over 1. So that's the difference between rational and irrational numbers. What I'd like you to do now is I'd like you to try to create the real number Venn diagram, the real number system Venn diagram. So you know what a Venn diagram is. One circle is inside of another one. All right. If you're unsure of how to try this and get started, what I want you to do is try to just make circles, bubbles, diamonds, triangles, some shape, squares, and try to think which number sets would fit inside of the other ones. If that's still not clear, I'll start you off by thinking I want you to make one really big circle, and I want you to label it as real numbers. And now think all the other terms we learned today need to fit inside of that circle or box or rectangle, whatever shape you're using. Need a little more help? Well, what we can do now is I want you to think I have to put, here's a circle, and I got to do natural, whole, integers, rational, irrational. Those are your 5 terms that we did today. They somehow need to fit inside there. I can't move one at a time, sorry. They need to fit inside of there, and some of them have to fit inside of others, and some don't fit where. Try to put these items down here, try to take these things here, put them inside of this circle, and they all somehow have to fit together. Some of them go inside of one other, some of them don't. All right, I just want you to take a try and attempt at this. All right, lastly, here is the Venn diagram, and notice what fits inside. So take a look at one thing. Notice rational and irrational do not overlap whatsoever, and they don't intersect. Because remember what I said about irrational numbers, they are not rational. So if they're not rational, they can't go together. And then notice I have the integers inside of rational, because every integer is a rational number. All the whole numbers are inside of the integers. Remember I said integers are whole numbers and they're opposite. So therefore whole numbers must fit inside of integers. And then lastly, the natural numbers were 1, 2, 3, 4. And the whole numbers were the exact same natural numbers with one addition. So notice natural numbers has to be inside of the whole numbers. And they all fit inside of the real number circle like I asked. All right. And now that's actually not the entire number system. All right. One thing we'll learn this year is we'll do what's called non-real numbers or complex. All right, but we don't need to get into that today. So here's this lesson. Hope you guys enjoyed. Have a great day.